Welcome to my channel. In this video, you're going to learn about simplifying expressions with rational exponents. First, let us have a review about radical expression because we need this in simplifying. So I have here nth root of a. That is what we call the radical sign. That's the index, and this is the radicand. Now, I have here example of expression written in radical form. This is the square root of 4. But usually, if it is square root, we don't need to put this 2 anymore as index. Understood? If there is no index written, it's 2. That's why it's called square root. So now, in simplifying, what is the square root of 4? It's just simply asking for what number raised to 2 that the answer is 4. So that number is 2. So 2 raised to 2, that is equal to 4. So the square root of 4 is 2. So same thing here. What is the cube root of 8? It means what number raised to 3 that the answer is 8. Which means what number that if we're going to multiply 3 times, the answer is 8. So we have here 2. 2 to the third power, that is equal to 8. So that is 2. The cube root of 8 is 2. Same thing with the fourth root of 81. What number raised to 4? The answer is 81. So that is 3 because 3 to the fourth power is equal to 81. Now, so let's simplify expressions with rational exponents. If you haven't watched my first part of simplifying, please watch. I showed there the derivation of these rules or definitions. So here I have a raised to 1 over n. That is equal to the nth root of a. This is the index, that's the exponent. Or if I have a raised to m over n, the exponents here are fractions, okay? So that is the nth root of a raised to m. Or you can write it this way. The difference here is that here you are going to raise to a power before getting the nth root. Unlike here, you get the nth root before raising to a power. Now, another thing here is if we have nth root of a raised to n, the exponent and the index here is the same, that is equal to a, if n is odd number. But if n is even number, you need to get the absolute value of a. Why? Because this a can be negative, and negative times negative, even number twice or 4 times, that becomes positive. So now let's apply the rules. Convert to radical expressions, rewrite the radicand in exponential form, then apply the nth rule to simplify. So if I have 9 squared raised to 1/2, it means this is the index 2, which is square root. Means we have the square root of 9 squared. And that is equal to 9. Simply, you are just going to cancel this one now. Because the index here and the exponent is the same. So that is 9. If I have here I have 27 raised to 1/3, it means the index is 3, so that is the cube root of 27. So what number raised to 3? The answer is 27. It means that is 3. So in exponential form, 27 is equal to 3 cubed. So the cube root of 3 raised to 3 is simply equal to 3. So you notice the index here and the exponent is the same, and this is an odd number, the n, so simply that is a. So now I have here x raised to 0 divided by x raised to 2/3. Now, in dividing the same base, what are we going to do with the exponent? We subtract, right? So that is equal to x raised to 0 minus 2/3, which is simply equal to x raised to negative 2/3. So we have negative exponent here, but this one is fraction. Is the rule here the same as the negative integral exponent rule? Okay, let's see. So what is x raised to 0? That is 1. So that is divided by x raised to 2/3. And this one is equal to x raised to negative 2/3. So which means that if we have a negative exponent here, we'll just get the reciprocal of this. Understood, there is 1 here. And once we flip this, This becomes the numerator, this becomes the denominator. But once we flip, this exponent becomes positive. So which means, in general, if I have a raised to m over n, that is equal to 1 over a raised to m over n. Now, let's apply this rule. So I have here 27 over 64 raised to negative 2/3. So we need to distribute this one. 27 should be raised to negative 2/3 and also 64. And then after that, you look at this one, this is negative, so we can flip this too. This becomes the denominator and this becomes the numerator, but the exponent will be positive. Okay, then after that, we can write to radical form. That is the cube root of 64 and the cube root of 27. Now, this exponent 2 can be written here or outside here. So let's put that outside. So it's easy to simplify. So now what is the cube root of 64? What is that number that if you're going to raise to 3, the answer is 64? The answer is 4. 4 times 4, 16 times 4, 64. And then 27 is, cube root of 27 is simply 3. And then this one should raise to 2, and that is equal to 16 over 9. 4 raised to 2 and 3 raised to 2. Now I have here 9 raised to 1/2 plus 27 raised to 1/3. So we're going to follow the steps, convert to radical expressions, rewrite the radicand in exponential form, then apply the nth root rule to simplify. So first, we need to rewrite this in radical form. The index is 2, therefore that's the square root of 9. And here, 3, which means the cube root of plus the cube root of 27. Now, the square root of 9 means what is that number raised to 2? The answer is 9. So the number is 3. So 3 raised to 2, right? Plus, how about here, 27? That is 3 raised to 3. So now we can apply the nth root rule. Sorry about that. By just simply, we can cancel this one. That is 3. We can cancel also the radical sign here, and that is 3. So 3 plus 3, that is equal to 6. That's the final answer, or the simplest form. So now I have here the quantity 5x raised to 5 over 3. So first, I can rewrite this into radical expression. That is the cube root of 5x raised to the 5th power. Or I can also write the exponent here. So now, I can rewrite that. That is equal to, distribute this, raising a product to a power. So that is 5 raised to the 5th power, x raised to the 5th power. Now, this 5 raised to the 5th power, I can rewrite this as 5 raised to the 3rd power times 5 raised to the 2nd power. Look at this one. So I can easily simplify this. Okay, look at this. 5 to the 3rd power and 5 squared is the same as 5 raised to the 5th power, because when we multiply, we add the exponent. Same thing with x to the 5th power. This is equal to x to the 3rd power times x squared. So now, I can simplify. I can now get the cube root of 5 cubed, and that is equal to 5. I can bring that outside the radical sign. Same thing with the cube root of x cubed here. That is equal to x. So what we have now inside the radical sign, so we have 25, which is 5 squared, that is 25, and the x squared. And that is, the index is 3. So the final answer now is 5x times the cube root of 25x squared. So that's how you're going to simplify expressions with rational exponents. That's all for this video, and please don't forget to watch the first or the part 1 of simplifying. Bye!